In this lesson, we're going to have a quick introduction to scatter plots. Scatter plots are very much like functions where they are in graph form and they're showing a relationship between two sets of data. Okay, if we see a group going up, it's increasing. If it's going down, decreasing. If it's kind of all over the place, there's no correlation. So that is the most basic information about scatter plots. Okay, scatter plots consist of lots of dots, though. They might be just dots all over. And then you have to kind of draw a line through the center of it to be able to see what kind of correlation it has or what kind of relationship, okay? So they would have dots all over. Same thing with decreasing. You would have dots all over the area. That's why it's called a scatter plot, because it's dots scattered around. Oftentimes within a scatter plot, you also have what's known as an outlier. It's a point that does not follow the pattern. So if we were looking down here on this, if we had a point over there, that would be the outlier. It's a point that is not on the pattern. Okay, so this would be your outlier. Right. Little more in detail of what you're going to see today, where I talked about correlations. It's the set of data that are strongly linked together. We say it has a high correlation. So what's that mean? So up there in those original ones, I showed you pictures, okay? So the word correlation meaning together in a relationship. Correlation is positive when it increases, and it is negative when the values decrease, when they go down. So a lot of times when I try to figure out the correlation, I just draw a line straight through, okay? Notice that those are all in a straight line. That's why it's a perfect positive correlation. High correlation, high positive, it is still going in a positive direction, and they're pretty tight together. These over here, low positive correlation, yeah, they're increasing, which makes them positive, but they're all kind of spread out a little bit. This one, I couldn't draw a line either increasing or decreasing in it, so we would say it had no correlation. Low negative correlation, it's negative because if I draw my line through it, it's going to be going downward. So it's negative, and it's low because they're not real tight together. The next one, you can see that these are a high correlation because they're tight and they're still going negative. Perfect correlation is when they line up in a straight line. All right, let's look at some examples. So here's the type of problem that you're going to see on today's homework. You're going to see a graph and you're going to be asked what the correlation is. So the scatter plot shows what? Well, what's it showing? I can see whether it is showing, and my choices are positive linear, positive straight, positive with one outlier, negative going down, negative with one outlier, non-linear, meaning not straight, no correlation, or no correlation. They're all over the place. So let's look at that. So in order to figure out what type of correlation I would have, first thing I'm going to do is I'm just going to draw a line through my data. And I see, okay, that is going up. So thinking back to slope, that's going up. All right, so the scatter plot is showing a positive correlation. Okay, notice that one right up there. Think back, what was that one called? That's right, that one's called an outlier. Because he's way up there. So there is one outlier. So this is showing a positive, it's going up. So what's increasing? X is going up as our Y is going up also. So let's take a look. The options were positive, so it was positive, it's going up with one outlier because the X values increase and the values of the Y are going to also increase. Okay, and then we'll show you that. Show you how the outlier is up here. The dots are moving towards the right, so the X's are increasing, and the dots along the y are also going up. Okay, so I highly suggest you either use a snipping tool or something to be able to draw those lines over it and circle. All right, let's look at another example. The next part of this lesson is about interpreting data from tables, okay? So here we have a random sample of students that were surveyed and asked to list their grade level and whether or not they have a pet. And the results are shown. So these 6th graders have pets. These do not. So no pets for 6th, 7th, and 8th grade. Pets for 6th grade, 7th grade, and 8th grade. How many 8th graders have a pet? Okay, so we're just going to use our table. Find our 8th graders. How many of them have a pet? So we look at the pets column. That would be 23. So that's what you're doing. You're going through and you are going to analyze tables. Read for details as to what you're being asked to find. The next part of this analyzing data is we're going to be looking to fill in tables. So we're going to need to fill in the tables. So this one, a survey stopped a man and a woman at random to ask them where they purchase groceries, at a local grocery store or online. Results are shown in the table below, but some values are missing. We have to fill in the values. So this to me is like a Sudoku puzzle where you have some pieces of information and you have to figure out how to get the others. So let's look. If I look just at this women's column, I know that 21 of their surveyed women bought groceries in a store. How many bought online if there were a total of 39? How would I go about that? Well, I'm going to take my total and subtract my store so that I'm going to get 18. And as I fill that in, I'll then develop enough information to fill in other pieces. So look around. You can do this in lots of different order. Think about, okay, here I see there's the total number of people. Well, total women, total men, total people. 39 plus 35 equals 74. Right? So now I can look and I see my next section. How many men and women shopped at the store? Well, 21 women did and a total of 45. So I'm going to take my total of 45, take away my women, which is 24. So now I'm going to have enough information to continue plugging through finding the missing pieces. Well, I can't find the number of men that shop online because I don't know the total. So I don't have enough information to go that direction. But I see that they have the total amount of men here as 35, and I know 24 of them shopped in the store. So I can go sideways to figure that information out. I could take my 35, take away 24, and get 11. Then I have enough information to work my way down on the graph. Well, if I want to know how many shoppers were online, I have 18 women, 11 men, for a total of 18 plus 11, which is 29. So you're looking to fill in all the parts of a table. All right, as always, if you have any questions or need any help, reach out.